Hello everyone, welcome to our channel. Today we will start exercise 1.2. But before starting exercise 1.2, have a look at few of the terms. Just remember few of the terms. First one is rational numbers. Rational numbers are those numbers which can be written in the form of a upon b. b is not equals to 0. For example, 1.2, 8.6. These numbers are written in the form of a upon b, where b is not is equals to 0. Next one is irrational numbers. Irrational numbers are those numbers which can't be written in the form of a upon b. For example, 2.16788 up to so on. It will continue and can't be written in the form of a upon b. Theorem 1.2. It states that let p be a prime number. If p divides a square, then p also divides a, where a is a positive integer. Just remember this theorem because we are going to use it in some questions. For example, let p is equals to 3. 3 is a prime number. A is equals to 9. 9 is a positive integer. If 3 divides 9 square, then 3 also divides 9. If 3 divides 9 square, then 3 also divides 9. This is what theorem states. Similarly, 2 is also a prime number. If 2 divides 4 square, then 2 also divides 4. In short, we can write it as if prime number divides a square, then prime number also divides a. We are going to use these in the next question, so remember it. Theorem 1/3. It states that root 2 is irrational. We are also going to use it, so remember this also. Co-prime numbers. Co-prime numbers are those numbers which doesn't have any common factor other than 1. For example, 2 and 5, 3 and 7, 8 and 15. These numbers doesn't have any common factor other than 1. 2 and 5 doesn't have any common factor other than 1. So 2 and 5 are co-prime numbers. Question number 1. Prove that root 5 is irrational. For proving it to be irrational, we have to use the contradiction method. So let root 5 be rational. If it's irrational, then it can be written in the form of a upon b, where b not is equals to 0. And let a and b are co-primes. If they are co-primes, they doesn't have any common factor other than 1. Just remember these two things. Next, proceed. A is equals to b root 5. On squaring both sides, we will get 5b square is equals to a square. It's visible that 5 is a prime number and 5 divides a square. If 5 divides a square, then 5 will also divide a. This is what we read in the theorem number 1.2. If p divides a square, then p will also divides a. So, if 5 divides a square, then 5 will also divides a. Next, a is equals to 5k1. Put it in the equation number first. Root 5b square is equals to 5k1 whole square. On solving, we will get this and then this. B square is equals to 5k1 square. It's again visible that 5 divides b square. If 5 divides b square, then 5 will also divide b by theorem number 1.2. So, this is what we will get at last, that is 5 is a common factor to both a and b. 5 divides a, 5 also divides b. But we assume that a and b are the co-primes, that is they doesn't have any common factor other than 1. But after solving, we get that 5 is common to both a and b. So this is what we assumed is wrong. We assumed that a and b are co-prime and root 5 is rational. So it means that root 5 is not rational. Root 5 is irrational. That's it. You can write it as in this way. Let root 5 be rational number. Therefore, root 5 is equals to a upon b. A and b are integers. B is not is equals to 0. Let a and b be co-primes. Then a is equals to root 5b. On squaring, we will get this. A square is divisible by a. Then a is also divisible by 5. Then a is equals to 5k1 from equation number first. All these method that we have proved earlier. If you have any doubt in any step, then you can ask it in the comment section. Question number 2. Prove that 3 plus 2 root 5 is irrational. Again using contradiction method, let 3 plus 2 root 5 be rational. Therefore, it can be written in the form of a upon b. Here, a and b are integers. Implies keeping 2 root 5 on the left hand side. By taking 3 to the right hand side, we will get this. By taking LCM, we will get this. Then by taking 2 to the right hand side, we will get this. Now, since A and B are integers, so after solving the right hand side, we will get some integer, that is some rational number. Right hand side gives us rational number, so left should also be rational. Root 5 be rational. But this contradicts the fact that root 5 is irrational. We already proved that root 5 is irrational in the above question. Root 5 is irrational. Also, by theorem 1.3, root 2 is irrational. So, this contradicts the fact that root 5 is irrational. Hence, 3 plus 2 root 5 is irrational. That's it. Question 3. Prove irrational. First one is 1 upon root 2. Let's prove this irrational by using contradiction method. So assume let 1 upon root 2 be rational. If it's a rational, then it can be written in the form of a upon b, where a and b are integers. By reciprocal, root 2 is equals to b upon a. B upon a is rational. Why? Since a and b are integers, so b upon a is rational, which implies that root 2 should also be rational. If right hand side is rational, then left should also be rational. But it contradicts the fact that root 2 is irrational. By theorem 1.3, we get root 2 is irrational. So root 2 is irrational. Hence, our assumption is false and 1 upon root 2 is irrational. Similarly, second part, 7 root 5. Let 7 root 5 be rational, so it should be equal to a upon b. Root 5 is equals to a upon root 7. Here 7, a, b, all these three are integers. So after solving, we will get some rational number. Therefore, a upon 7b is rational, which implies that root 5 should also be rational. But we know root 5 is irrational. So our assumption is false and root 5 into 7 is irrational. Similarly, third part, 6 plus root 2. Let it be rational, so it should be equal to a upon b. Root 2 is equals to a upon b minus 6. Here all these three are integers, so after solving we will get some rational number. If right hand side is rational, then left should also be rational. But we know that root 2 is not a rational number, it's irrational. So it contradicts the fact that root 2 is irrational. Hence 6 plus root 2 is irrational number. This is how we solve all these three questions. If you have any doubt in any question, you can ask it in the comment section. Thanks for watching our video. Like and share.